Now we're looking at average value. You've done average value with one variable. Now we're doing average value of a multivariable function. So f of x comma y is x over y. And I want to find the average value that this function takes on over all the points in this region. And the region is xy, where x is between 1 and 5 and y is between 3 and 5. So obviously we're looking at a rectangle over here. And I want the average value that the function takes on for points, or all the points inside that rectangle. That's a lot of points. So the formula, there is a formula for that. And the formula is 1 over b minus a times d minus c. In other words, 5 minus 1 and 3 minus 5. So that's 4 times 2, which is 8. We'll get to that. And then I take the integral of the function itself, x over y. And this is the average value formula. And now I just got to crunch it down. I'm going to show you a little trick here. I'm going to show you a little trick. As far as we're looking at the inner integral. At the inner integral, the y is a constant. So I could take the y out of that first integral. Not out of the second integral, but out of the first integral, and put it right in there. Then I have an integral with an x and no y's at all. So I could take that completely outside of both integrals, and I'm left with this. I'm left with, well, this is 1/8. The x and the dx goes all the way out, comes all the way out here with the same 1 and 5 that I have. That same 1 and 5 is out here now, and the 1 over y is over here in the dy, and all this works. Now I can't. It's not always possible to do this because it's not always possible to separate x and y so neatly like this. But here x and y are quite separable, so I'm able to do that. Now, I do each integral separately. So this is 1/8. This is x squared over 2, evaluated between 1 and 5. And I'm multiplying that times this integral, which is ln y, evaluated between 5 and 3. So it's 1/8 times this times that. And that comes out to be 1/8 times 5 squared over 2 minus 1 squared over 2 times ln 5 minus ln 3, which equals, well, by the way, that's 25 minus 1, which is 24, divided by 2, so that's 12. 12 over 8. And here I have ln 5 minus ln 3. I wrote it a tiny bit shorter. It doesn't really matter at this point, but, whatever. I had some space. I reduced 12 over 8 to 3 over 2. And I wrote, instead of ln 5 minus ln 3, I wrote ln of 5/3, which is the law of logarithms property. Either way, the problem right now, I want to change this to a decimal. So this is the exact answer right here. And as a decimal, that comes out to approximately 0.77.